All right, welcome back, everybody. This is the Virtual Residency Workshop 2026. It is Thursday, June 25th, 2026. This is our second session of the day. It's a panel titled Mapping Research Requirements to Software Tools. Our moderator is Ashley Elias from Missouri Western State University, and I'm going to turn the show over to Ashley to introduce the panelists. So go ahead, Ashley.
Hi, everyone. So we'll just start with introductions and I'll let the panelists introduce themselves. So maybe we could start with Jacob. You're muted.
Yeah, I noticed that. It's always fun to speak to yourself. So I'm talking to myself. Yeah, my name is Jacob Fosotande. I am a research computing architect and solutions developer at the North Carolina State University in Raleigh, North Carolina. So as a research computing solution architect, I design solutions, and one of the problem I face is deciding what software to use or how to map software to my research requirement and discuss with my researcher to figure out what is the best approach. Thank you.
Great. Greta?
Good morning. It's great to see everybody here. I'm Greta Kellogg from Penn State's Institute for Computational Data Sciences. I'm an assistant director for our Center for Applications of AI and ML to Industry. And my background and research focus are high performance computing architecture, open science, data curation, and accessible, reproducible scientific software development. Glad to be here and see everybody. It'll be fun.
Abhishek?
Hi, hello everyone. I'm Abhishek, a research computing facilitator at New Jersey Institute of Technology. And as facilitator, my job responsibility is, to assist the users with their workflow who use our computing cluster resources to conduct their researches. And I'm also responsible for maintaining and installing the software packages in our cluster.
Great. Thanks for being here. Rajesh?
Hi everyone, good morning. Myself, Dr. Rajesh. I'm working as associate scientist from the Frost Institute of Data Science and Computing. And my role is the integrated role between the advanced computing and data science. And we will try to provide all HPC and AI-enabled custom services to different disciplines in the universities, both faculty, students, and researchers, and sometimes mid-sized companies too. And also with the help of Henry, we are also providing the regional computing services to other universities using NSFCC star. Thanks, Henry, for the advisory panel for us. Thank you. And I'm very glad to meet you, everyone. Thank you so much.
And is it Dina?
Yes, my name is Dr. Dina Tandabani. I'm a professor of chemistry at the Clark Atlanta University. I use my group use high performance computing in different locations, and we use a variety of softwares from for DFT, ab initio, and molecular dynamic simulations. As my role, I also help other faculty in our campus and graduate students to identify the software as well as the supercomputers to use for HPC or data analysis. Thank you. Happy to be here.
Great. And finally, we've got Ted. You could introduce yourself.
Sorry, it took me a moment to unmute. Yes, thank you. So I'm Ted Austin. I am with Federal Reserve Bank of Cleveland. Right, I serve as the expert solutions architect and technology strategist here in our research department. What that means in many cases is understanding what our researchers' needs are and how to make them work inside the Federal Reserve Bank. We work very much differently than much of the bank, right? So for many things, right, we don't show our hand or talk about what we have. But for our researchers, they work with external co-authors. They publish a lot of different work. So we need to figure out how to enable them. So providing technologies, figuring out how to procure those technologies and what's going to work. Also, I work directly with the researchers in terms of AI and enablement in how we're going to get a thing done within the constraints of our environment.
Great. So I think the participants can enter questions whenever they want in the meeting chat. And if you have something, you can raise your hand. We'll also have time, depending on how we go, but we should have time at the end for questions. I also put the notes doc, the Google Doc that's from the shared folder for all the sessions in the chat if you want to take a look at the questions that Greta kindly prepared for us. So we can probably divide the questions up into 4 phases. And so we'll kind of take you through intake and discovery, evaluation and selection, whether to build or adopt something that's pre-existing, and maybe some learning experiences, all related to software evaluation. So maybe I'll start off with our first question. So maybe a common experience is a vague request. So researchers come and say, I need to analyze my data. How do I even start? So what is maybe your go-to strategy or framework for unpacking what the actual software needs are? And maybe we can go in that same order that we started with. So maybe Jacob can try first.
Yeah, so uh, my role is a little bit different. So in most cases, I have to create we have to create the software from scratch. So since I mostly work with a bigger project, mostly interdisciplinary, and so we have a lot of edge infrastructure, and we collect data, store, compute, publish. So in all of these stages, we can develop application on the edge, whether we're flying drones and we're collecting data, or we're doing machine learning uh, we're doing machine learning to help lab scientists identify some organisms. And then we build the dashboard, train the model. So we have to create everything from scratch most of the time. But we'll equally learn how to adapt and pick solutions that already exist. I look mostly into industry. So the approach is having a conversation with the researcher. Sometimes they have a good idea of what they want. Other times they don't. So you have to figure it out. And I use a software development approach. It's very iterative. Whatever we do, we start first of all with a proof of concept. Find the very basic parameter, share with them, get a little bit of understanding. They give the green light, we build something, and we start moving from there until we get the final product. And when we get the final product, we pull out lessons learned. What did we learn from this? And we have one tool in our toolbox. If we have another project down the road, we'll look back. Can we pull out from what we've already done? If yes, we'll start from there. It will be a starting ground for us. But most of the time, we don't have applications that are readily available. So that's in my current role.
Great, makes sense. Greta, do you want to add anything?
Yeah, a lot of what Jacob was saying is a lot of, how I start as well. You start with not thinking about given software, but you help the PI unpack what it is that they want to accomplish and start by defining, what does success look like? What decision, what kind of output are you trying to produce? What data do you have in what format? And working with them, we do have a software stack. Not everything has to be developed in-house. And we do have researchers that create their own workflows, but we also have people who would leverage Pegasus or Galaxy or other workflow tools, and different kinds of software modules for that. And so talking with them, as Jacob was saying, and really finding out what they're trying to accomplish and kind of pulling that conversation away from any particular software, I feel is really helpful for getting started.
Makes sense. Abhishek, do you have any comments on a good starting point when trying to identify software needs?
Yeah, so when as Jacob and Greta said that whenever they ask for that, I need to analyze my data, so I need to sit with them and want to know the more context about that so that we can help. So if they first, I generally ask what kind of resources they require, so like whether their workflow require any CPU, GPUs, or parallel computing. So if their workflow is based on GPUs, that means they might need PyTorch or TensorFlow. So in that case, we also have documentations for how to create the Python environment. So we system-wide install Conda. But the user responsibility is responsibility to create the Conda environment where they can install the Python packages by themselves. So we don't maintain the Python packages system-wide because all the Python packages, the versions vary and lots of dependencies, and it varies from user to user. So we just created the Conda as module, but it's user responsibility to create a Conda environment and then install all the packages by themselves. And yeah, so when they talk, once I know the details about it, based on that, I help the user based on what kind of data analysis they require.
I think Rajesh was next.
Hi, I will try to agree with all panelist discussions, and I will also add few things. And most of the things, sometimes when researcher comes to analyze the data, he will try to discuss some points with the PI, and then he will came to know what kind of tools and what kind of packages he needs. Or sometimes he don't know anything, he will try to directly come to the HPC team and ask, I need the analysis. So we will try to impose most of the questions like people said, what is the volume of the data, what kind of data type it is, whether it is no code or code required. Sometimes psychology people will come to us, hey, I want to analyze the behavioral analysis. So how efficiently they are able to do the code. We have different kind of tools like code and no code, Azure Machine Learning Studio, NIME, Power BI, Tableau, and similarly different kind of tools for Jupyter Hub on HPC, whether it is single node or image oriented analysis, text oriented analysis. So we will ask these kind of different questions to understand, and most of the thing is goals are very important. So everyone will come up with data and what goals he is trying to accomplish. And based on that, we will try to map the right software tool accordingly. If he knows, okay, or if he don't know, we will try to ask these kind of questions and map the kind of software tool accordingly.
Makes sense. Dina?
Uh, my situation is more like what Rajesh mentioned. Like my school is very small, and there are only handful of faculty do the computational research, and they come up with no idea, no clue, and they have like I have this data and I don't know what to do, right? Many times, and then I explain and I ask questions. Like the questions lead me to answer, then I tell them the resources. Sometimes they go to the resources and they still struggle. I spend some time to make them to in a path that they can go independently by themselves. That's what I do it in small place, small school. So thank you.
10, your situation is probably a little different.
It is a little different, but I will say a lot of what everyone does here, I think, is pretty common, right? I do start maybe a little bit differently in how I approach it, and I think this is more of a personal kind of preference approach. But I really want to start by letting their interests drive the information sharing, right? So I start off, and if they come to me and they're like, "Oh, I've got this problem," or "I'm trying to figure out how to, analyze this data," or usually it's I'm having trouble because they start down a path, right, that they thought was going to work, and then something about the structure of this just isn't what they're used to. So I like to back up the conversation and understand, hey, what are you trying to get done, or what are you hoping to get out of this, right? Really trigger their excitement and their interest in the data and in the project, and so they're sharing the project, they're sharing that idea while I'm listening to that, right, use my analysis skills, kind of take down notes as they're talking, right? What are the hooks? What are the pieces, parts that they've mentioned? so that then the next phase I can go back and say, hey, I think that's a great project, right? You mentioned, this data or that, and how you wanted to do that, right? And then we go ahead and we start asking more questions and digging into it there, right? It helps change the perspective of how they approach the conversation. They don't feel like they're losing time necessarily because they're talking about something they're excited about. But then you can go ahead and trigger on a lot of the pieces, parts that matter to them. And then usually I'll just follow up, right, with a summary, kind of parse it down, somewhat reductive, but say, okay, so it looks like we're trying to, collect this data or use these together and then, right, do this process. We don't need to call out solutions as we go through that, right? Just try to get a common understanding of what the overall process is expected to be. And then ask if I can, suggest some of the observations or thoughts, and then move into, okay, we both understand this. Here are some elements of what the technologies that we have already in place that can do this. Here's where some of those may be a problem. And do you think we need to dig into new or other technologies that aren't available to us yet, and move the process down from there?
So it sounds like several people touched on this, but how specifically do you handle situations where a researcher is dead set on a specific tool that they saw on Twitter or a colleague suggested, but maybe it's the wrong fit for their specific requirement? Maybe Greta could kick us off for this one.
Sure. Generally, I like to always approach it like the faculty member or the researcher, the grad student, they have a reason for why they want to choose what they want to choose. And it's probably a really great reason. And maybe like all of us in these research fields, we don't know what we don't know. So I'd like to start the conversation by, what are the constraints that are most important to them? Like, are they worried about privacy, or are they in a time crunch? Is there no budget for licensing or software? Or do they only know how to compute on CPUs? They don't know how to do any kind of compute workflows on GPUs. Is it something where, find out like, why do we have to use Excel for everything? Why does everything have to be R? And then once I understand like what their really great reason, because they have good reasons. And then we break that apart to, what matters most? Like, what is it that we're trying to accomplish? And then take the conversation, like we talked about in the first, but away from any given software or any given tool, and just focus on like, okay, what are we trying to accomplish? What are the constraints? Because there's a reason for why they're locked in and on what they're locked in on. But then kind of transition into, well, what is it that we really want to accomplish? And sometimes, like, if they had just have a few figures that they need to crank out for a publication or an abstract, yeah, go ahead, use Excel. Like, for like a proof of concept for just a little bit of data. But if you're saying like, no, I need reproducibility for large scale, for big data, then let's have a different conversation about like, well, have you ever noticed that these tools have not been very good at that in the past? Are you interested in looking at some other options? So a lot of words, but that's kind of.
No, that makes sense. Maybe I'll open it up to the rest of the panel for time we move to evaluation and selection. If anyone else has comments on managing expectations, you can go ahead and unmute yourself.
Yeah, so
okay, yeah, sorry.
Abhishek.
Oh, okay, thanks. Yeah, so in sometimes I've seen that just as Peter mentioned that some they do have valid reason, and also sometimes I see that they just unnecessary, they just saw that one of their colleague use it for some cases, and they want to use it without any proper reason. So first I need to sit with them and ask them what their end goal is. and in some cases we are unable to use the software packages because their colleagues might have used it in their Windows version of their workstations, but that software version doesn't have any Linux version, so we cannot install it. So we sit with the researchers and find the end goal, and then based on that we talk about some alternate options so that they can achieve the same.
Rajesh, I think.
I will try to add some more points to that one. We have seen some kind of cases like people will get some GitHub code from the other environments and trying to execute that in the local HPCs. And hey, this is not working. Sometimes they will try to say, it is working in my local laptop. It is not working in HPC environments. Compatibility versions, OS versions, drivers. And similarly, nowadays everyone using the Chat GPT and Copilot. So if you understand really the code environment, what actually it meant for trying to execute that one, don't it will whatever the prompt you have given, it will give more than that what you asked, and comments and commands too. If you try to execute all those commands in the Linux environments, HPC is very critical and shared environment, and we are providing 24 by 7 services to all people. Because of you it struck, it may be a problem. So my opinion is try to understand each and every command statement before executing on the HPC and AI systems.
Yeah, so what I'd like to add is that the faculty, I'll take my case for, I cover an entire university and projects can come from any angle. So I'm not going to pretend that I know everything, but I'm just going to open myself up for any new stuff that shows up and apply curiosity and try to understand what they're asking, the requirement. And I've learned a lot from faculty because they are the expert in the field. They have collaborators. They know what type of software is being used. Now, it's my job to figure out how does this fit to the cyber infrastructure that we have at our institution? How can I even make it better? So I'm working on a project, interdisciplinary, multiple PI. There is one PI that doesn't know how to use this, and you have to set it up, install it, but she's not a fan and she will never use it. So I'll figure it out. Oh, there's Open on Demand. How can we package this? Maybe we put it in a container and deploy it on Open on Demand so they have access to it, so they can use it, whether on the H job lab data or to manage their machine learning jobs that they're running or their graduate student is running. Uh, So, um, so from my experience, I've learned to ask the PI for suggestions. What do you think? What is common in your area? Because my workflow is not one application, it's many applications. Then it's my job to figure out how to put all the pieces together in a way that makes sense to them and that can facilitate their work. They're expert scientists, they are not application developers. I want them to do the science and we'll focus on building the infrastructure.
That teed us up really well for our next phase, which is evaluation and selection. So when you're evaluating these packages that claim to do things that maybe are very similar, or you have alternatives that are out there, what are the green flags or red flags? What are the good things you're looking for, or what are the things that might steer you away from something? How do you evaluate what would be a good fit for the project? So maybe we'll start with Abhishek for this one.
Sure. As Rajesh mentioned earlier that that some students tried the GitHub projects on the laptop and then it's working, but it's not working on the HPC. So when I looked at those, Jenny looked at those those repository, and if I see that those are because sometimes I see that those repositories are not maintained properly. So maybe those are 10 years old, and these are not compatible with now OS versions. So in that case, it's kind of red flag because it's not maintained properly. So in that case, I sit with users and ask them again what's the end goal and look for the alternate solutions. But somehow, if they really need this kind of software, then I suggest them to use container instead. So I help with the users to create a container so that they can container based on old OS version so that those software may run.
Rajesh is nodding. Do you have anything to add?
I would like to say general thing in the software evaluation. Evaluation of the software tool is very important. Why? Because generally we will try to take it as a 5 pages, 5 phases. So we will try to transfer the real-time problem into the research statement problem, and after that research statement problem, we will try to select the proof of concept as technical feasibility of the approach. So there we will try to do the evaluation mostly, and in that part we need to do what kind of tool we need to select, what kind of AI model we need to select, what kind of algorithm we need to select, what kind of approach or packages or libraries we need to select. So that kind of evaluation is necessary. If you are not done earlier, and if you randomly select the someone suggestion and research workflow, so before that transferring the research statement to proof of concept, we need to have a research workflow. What is the input size, those kind of stuff. So based on the research workflow, you need to select the right tool, and evaluation of the tool is mandatory. So if you are not doing in the proper way, if you select one thing and if it failed after 2 weeks or 1 month, the total resources what you used and support team and research time, everything will be wasted. So first you go for the research requirements phase and translate that into the evaluation of proof of concept is very important. So according to that, and fourth phase we will try to discuss is execution phase on the small subset of data on the single node or multi-node, then uh, generate to the accelerate to the multi-node or GPU accelerations. So everything is always continuous and iterative incremental approaches. So these phases need to go properly, or else it will be collapse at any point of time.
Uh, in my case, evaluation comes, it's very challenging because our IT supports only most of the time, 99% of the time only for the teaching. So they don't worry about the research computing. I'm one of the persons in the campus having like a 10 workstations and try to do it in my lab, in my research lab with the PhD students or maybe sometimes scientists working there. But when it comes to an IT, if some other professors wanted to install some software in their university provided machines, they do not have administrative privileges to install the software. IT refuses maybe almost like 6 months or something, then they may sometimes ask me if the professor knows directly come to me, then I can go to IT and I can help evaluate. But sometimes after so long time, IT contacts me and they try to tell, okay, this is reasonable, this can work, and this is well-known software, and I have to provide some evidences of published papers based on the software, then it works. And maybe supercomputer centers examples I give them, then it works. Otherwise, it won't. But again, when it comes to Windows based, or because it works in different platform, different operating systems, when it comes again, efficiency problem comes because sometimes something works very well in the Windows or OS side, something works very well in Linux. There's even same software is there. Sometimes Mac OS. As university again says, with the Windows based, no problem. When it comes Linux based, they should be on their own. And they even take the machines, they won't allow the machines to be in the network. So there's a special permission is needed. So both it's a hardware as well as software. The evaluation goes very strict in some of the schools. Thank you.
Ted, any thoughts?
Yeah, so I mean, we have the restrictions on our network, but researchers will come and they'll say, "Yeah, I've got this software that I want to run, right? So how do we evaluate it?" I think a lot of people have said the right things, right? You see how common it is, whether it's been run other places, right? When it's something that is really esoteric or no one's ever kind of run this before, right? It needs to have a little bit more evaluation. Similarly, we will look at the software and do the evaluation ourselves. I will say my red flags are things that are overly complex or require lots of additional support software or other setup or configuration, biasing towards whatever is going to be simplest to get the implementation in and allow the user to continue to work without my oversight or assistance is really where we want to continue to push things, because we don't ever want to stand in the way of the person as they're getting it done. Right. So I think it's a little bit of the consideration of, can we do this without any admin, credentials to install or to operate? And can we do this in a way that the end user, who's an expert in economics in my case, doesn't need to know complex details about it? And ideally, can we get it running as close to native Python and not necessarily create large memory issues by using packages that maybe add overhead that are unnecessary.
Greta, do you have any comments on evaluation and selection before we move on?
Yeah, so I think one component has been left out, which is really the financial component and the long-term maintainability of the software and how you factor that out. So generally, I will categorize my software into a number of categories. So you have software as a service and open source software or licensed software. And so now the faculty or the PI comes in depending on the budget of the budget that the project has, the goal of the project, and the long-term planning. So if we have a project where we have a number of external stakeholders that would like to get access to the output of the research, that implies that I'm going to have to develop a dashboard. And so from a level point of view, it's very expensive from my developers to do that. We can do that, but it will take longer. There are alternative software as a service which may be provided by the cloud. Now, does the budget has the funding to pay for that now and down the road? Or there is an open source software. I'll take an example, MLflow, for example, which is really good for managing AI and ML workflows. You have a number of people working on the project. They want to see who is doing what, how many trainings have been done, what is the champion model. You want to set that up. And you could have the commercial version, or you could build. In our case, it would be better for us to build something from the open source that is available and maybe integrate it into our open on demand. So we can use it for that project, but down the road, if we have another project, we'll use it. And that way we cut down on the cost. And so if we are developing a dashboard, we could build it, but it would be better to use software as a service, which may be provided by some of the cloud provider, and that will cut down on the development time, but the project will have to pay for the infrastructure that is being used. So I can give all this scenario to the PI or the project lead, do the evaluation, do the cost analysis, hand it over to them. They go down, sit and figure out what is the best option for them. And then we'll go from there.
Greta, any thoughts?
I think the panel covers it really well, and Jacob's really good point of like the long-term maintenance and cost always has to be part of the conversation. So then the only thing I would mention is the better the documentation from that first step, so that you can make sure that when you do the evaluation and you're looking for red flags, and then you can present the data back to the researchers and say, okay, based upon the criteria and your objectives, now we can look at those costs over time.
Okay. So
one thing that I'd love to hear from, because I can tell like our panelists come from all different size schools and managing different cyber infrastructure. Do you bring that into the conversation then when you're talking with your faculty or your researchers? Like the security requirements of your specific situations, and if Linux wasn't allowed on our networks, oh my gosh, there would be a revolt.
Yeah, so I think that is a really a challenge. The academic infrastructure traditionally was built for enterprise IT. And so from a research standpoint, especially when you're moving data, sometimes you're streaming data and people, you have a PI streaming. I have one case that just happened a few days ago, and he's just moving, I don't know, maybe thousands of files. And then the firewall is kicking the application out and has no idea what is happening. He comes to you and he's so mad. And you take a look and you go, oh, yeah, I know what the problem is. So, but you're going to have a discussion with the higher ups on the importance of having a network designed not just for enterprise, but for research as well. You can have a research or science DMZ specifically for research activities, especially if you're moving data. So people will stream data most of the time, huge amount of data. If you are a university like such as mine with extension uh, stations where you have data constantly being collected, you really have to think about something like that because it's going to be a challenge down the road. Yeah, but from the security point of view, so it's mostly about the data. So when they describe the type of data that they have, so on our campus already, we have various layers of data. So whether it's the red, green, yellow, now you determine what to deal with. So I deal mostly with open science, but if it is something that has to be done in a secure enclave, so I would direct them to the appropriate group to help them. So it's a collaborative effort. So I know what I can do and what I should not do. And if I don't understand, maybe I'll contact some of my colleagues and have a discussion so to get an insight, or just post and ask whether somebody has done something like that.
And I'll just respond from the Fed side, right? We absolutely have the conversation of security with our researchers as we talk through it, how data are treated differently depending on the source. Even open source data, if it's procured through a contract, right, is going to be treated differently than open source data, which is procured directly from the open web. So these have become very common conversations and something that the researchers have adopted too well. The other side of the question that you had was around right some of the costs and what do the structures look like there. Um, Traditionally, that hadn't been part of the conversation here, but as things are moving, right, with AI and other costs as things move into clouds, right, literally the finance cost models are changing, and we're having to bring that in. One of the things that I know that we're trying to do, and that I'm doing my best to kind of champion around, is reducing the conversation around costs such that it is a significant limitation factor, right? I don't want to add that additional cognitive load to a researcher to have to determine, well, now is it worth it to go ahead for me to do this exploration, right? If I don't know whether it's going to be useful, right? And do I get rid of my budget now, on this item? So I think that's one that overall, right, as a research community, we have to start thinking about, right? How are we going to hamstring real research if we're constantly having to put decisions before our researchers to say, okay, you got to decide how you're going to spend your pennies to get this done. But we also know at the same time that there aren't unlimited resources.
Any other thoughts on the unique challenges of your institution? So our next set of questions is about building versus buying or adopting. So evaluating when to code and when to not code. So what is your philosophy about adopting existing software versus building your own? Maybe we'll start with Rajesh.
My perspective is, first of all, don't try to build the software. First, look what are the options are available. At the same time, we are have plenty of options for every kind of task nowadays. What is the feasibility of approach? If it is necessary for custom building, and you need to, if suppose if you want to do the tasks for next 1 year, you need to be get ready building the software right now. So then only it will be work accordingly. And at the same time, you need to see what is the cost model and installation paths as well as compatibilities, driver. So HPC is always like a ocean. Everything will comes to us. Uh, Medical, biology, engineering, anything. So when you are building a custom software for the HPC, you need to think of schedulers, you need to think of the nodes, you need to think of the drivers and kernels and OSs and GPUs. So many compatibility versions and issues will be there. So you need to be address every single part of the thing, and you need to test it thoroughly before releasing into the public. So sometimes it will work on particular things, and when you release it, it may not work properly. So custom build should be more carefully do properly when building the things. That is the thing I would like to mention.
Dina, do you have anything to add?
Yeah, I agree with what Rajesh said, because the cost and the human, right? So because the human capital, that's not easy. If somebody has like a 10-member group, they can build it. They can customize it as needed for different reasons. But if we don't have people, if we have one or two, and I will look at the right software for adopting, and if needed, we can modify it as needed in that if we know overall. That's what I'm practicing for my own group. But my other professors come in there and when they come with the overwhelming idea of doing that, but I say realistically, how much time will it take? Because when I was asked that, oh, you can do the build the cluster, you can do the small big cluster for you, for us, for our university, that's right, but we know the cost of maintenance, right? That's a key. And also the some of the commercial softwares are hugely expensive. On the other hand, I can use the softwares in the supercomputer centers, which is cost effective, and we can access 24/7, no problem. If there is a maintenance, somebody is taking care of those, and NSF invested money, DOE invested money, right? So we can take advantage of those situations. So I most of the time I go with adopting model than building. But if it's needed to create a small patches and other things, that's what I'm practicing it, and I'm also suggesting the same thing in my institution. Thank you.
Ted, any thoughts?
Yeah, so I'm very much a person who doesn't like to use the budget if I can avoid it. I very much look at, hey, how can I get this thing done? And a lot of times I'm reaching for the open source tool. It doesn't have to be a direct fit, right? I want to find a tool that I can utilize, right? You need to be mindful. Is it going to be long term? Will it be stable, right? Will it be secure, right? And those are things where you have to think about your whole environment, right? Is it something that I could just stick in a container and it's going to be able to go? It doesn't matter for the next 10 years. I would then, right, if it's something that needs a little bit more, I go towards thinking about low risk adapters that I can then build around that, right? Because we don't want to have to maintain these things for a long time. But if we can build a simple API that goes ahead and does something in between, right, we may be able to operationalize what we need very easily to do that, right? And I think to the point that some others have made, purchasing is a good thing for us. A lot of times it is, right? How do you offset your risk? If it's something that is public or that is a needful part of what we're doing that needs to be reliable, I don't want to risk losing the one or two people in my organization that maybe continue to know what the details of this developed solution are. So that's when I start to reach towards purchase solutions for things like that. When it's important to offset risk, that's especially a good reason.
Jacob, it sounded like you lean more towards custom solutions. So do you have any advice for writing your own software solutions?
Yeah, so I would say it's not um, r- coding or not coding. It's not, it's like a binary question where you say yes or no. So it depends on the situation that you face. I'll take one example. I'm working on a project and I want to use Globus Compute. I prefer using Globus Compute. And in order to submit the job, I have to set it up on a cluster with LSF. Unfortunately, one component, after investigation, it took me a couple of maybe weeks or months. I figure one component is missing that will enable me to allocate the resources before Globus Compute can kick in. Should I buy that piece of software, or should I look for a hack for Globus, or should I just ignore Globus Compute and build a script that will submit the job, monitor the job, and then uh, archive the result in a database? It turns out building it is way better and faster than trying to hack or pay for a piece of software that maybe only the project that I'm working on will benefit from it. It doesn't make sense, economic sense at all. So it makes sense to build. So it depends on the situation that you have at hand. Sometimes it makes sense to build your own, and other times it makes sense to just adopt what is available. But even when you are adopting, you need to figure out how easy it is to do, or are there alternatives that you can easily run through? Because at the end of the day, time is of essence here. And you don't have the project, the PI wants the project done. They may not say anything, but we know if we are too slow, they start grumbling and they can just ignore us. Um, so you have to think about the time that you need to complete the project in order to figure out what piece of software you need. And you equally need to see how well the piece of software that you are considering will fit into other pieces. So I deal with ETL, compute, publish. And so if I'm looking at some piece of software at the ETL stage, how does that fit well with my compute stage? Or how does that fit well with my publishing? So I have to look at all of those. Does it make sense for me to pay for it, or does it make sense for the developer to develop it? And if yes, then I'm giving myself a lot of work. But if we can gain from that, yes, I rather we build our own application and use it for other projects that may come down the road.
Greta?
Oh, just looking at I tend to work with teams where we build solutions, but we build them over long term. And so I really like what Abhishek was saying earlier about building containers for specific solutions where you're providing a solution for people that can run on the system. I just want to mention that at Penn State, we're kind of splitting apart people who are working with pulling AI methods and machine learning methods into their analysis and into their platforms versus giving and providing tools like Claude Code, Cursor, and GitHub Copilot to the graduate students and to the faculty for them to develop their own proof of concepts and quick pilots and solutions so that they can be part of the conversation. And then we're looking at, because all of this is kind of so new, about whether or not that kind of helps us with the maintenance conversations later for anything that we're building with them, because it makes it almost inexcusable to not have these platforms help create really great documentation as we go along. Like one of those things that it's hard to do when graduate students are defending and leaving. There's a point where I feel like when faculty would look like, okay, we want to work with outside contractors, it was hard to balance that. But now some of these tools are so robust that it's like, well, we can develop good proof of concepts in-house. And that kind of helps alleviate some of that, because the thing with the contractor issue is it's really hard to maintain the funding for that over time.
That's a good point. One of the questions I didn't read out was when and how you should involve outside consultants or contractors. So if anyone has any thoughts on that, we could go around. Maybe Abhishek first.
I mean, contractor, I'm not sure because we didn't have any kind of situations where the thing I can actually add with the current question about the existing software versus that advising researchers to develop their own custom solutions. So particularly, I generally want to avoid the researchers to not to develop their own custom solution unless that is really necessary, because most of the cases, based on my experiences, I see that most of the cases users don't know actually how to compile their codes, and they are not aware that already there are lots of dependency software are already available in our cluster. So for example, GROMACS, it's an open source software which is we have different versions available in our cluster. So if users requires any kind of newer versions, then I usually go for it and install it system-wide. But the challenge is when they require older versions, and then I sit with the researchers or the other graduate students to understand that why they need the older versions, where the most of the that with their workflow is already done with the newer versions. So sometimes they have some kind of add-on packages where they build by the custom add-on package, which might not be compatible with the newer versions. Then I sit with them and look at the details documentation so that I can help them to install it with the which is compatible with the newer versions.
So our last kind of, once you've done your intake with your researchers and you've evaluated some of the software you've decided to build or buy, could you share any of your experiences, whether there were challenges or success stories or specific examples that would help others in the same situation?
Can I just hit on
Sure.
the need to get the outside consultant?
Yeah, of course.
Yeah, so what I've noticed is that sometimes you're working on a project, and so there is a section of your project that you probably will be using a system that has been set up, and that the vendor has a better understanding of the system than you do. And so you have to want to integrate that piece into your whole software stack. And if you want to do it, it may take a very long time. And so that's when I bring in the outside consultant. So why they help out integrate, which is, I'm thinking here, for example, I'm thinking of a case where, so you have a model that you've trained, and you've got your champion model, and you are ready to set up a dashboard or some sort of a microservice to do some inferencing on some cluster with Kubernetes on it. I'm thinking here, publicity SaaS Via. I don't have a background in SaaS Via, but just looking at the specifics of SaaS Via, I see that it could be a very good place for us to deploy our inference app. And so in that case, we'll bring in the consultant. But what I'll try to do is I'll bring a couple of our developers so we can have some sort of a transfer of knowledge. Consultation will build that inference application, use it, and then while they get their money and leave, we get the knowledge. And then next time we'll be the one doing that, not calling the consultant again. So that is one place where we can actually take advantage of. And you could think of other ways as well. So I don't know. So there are other ways of deploying AI model where you can equally look for an NVIDIA consultant to set up, I don't know, agents or whatever system that you're trying to build and that you're trying to automate the process. And you don't start off having the skill set, but you want to learn and have that acquire that knowledge at your institution. So it makes sense.
I would like to add some more points to the Jacob in terms of consultation. So when you need to go for the consultation, you need to be more careful about the sensitive data like medical HIPAA compliances as well as GDPR. And when if it is necessary, if the internal resources are very limited, and if you think the particular vendor support is very strong in the particular case for the consultation, then go for it. And also you need to take care about the intellectual properties. If suppose someone developed some kind of sort of the thing, who owned it, either vendor or particular research team who given to it. So universities and companies collaborations, intellectual property rights and copyrights are also need to be defined properly when you are giving the work to the outside environment. So you need to take care about those kind of things. And similarly, for the custom build, if suppose if you think research is a long term and specific approach, custom build required, then try to build by taking some internal students or graduated PhD scholars in the department or environment itself. Don't give to the consultation. Yeah, that's it from my side.
Their thoughts on outside contractors or consultants? Okay, so for the last kind of phase, the success stories or the challenges or experiences, maybe some of the participants, either you can type it in the chat box or you can raise your hand and then unmute, and the panelists can share their thoughts, but you can also participate and share experiences or success stories that have to do with any of the things we've touched on. Don't all rush to raise your hand at once.
Can I go?
Of course.
Yeah. So from my experience, where when you're helping researchers with research that require either developing new tool, the beauty of it is that you start up not knowing anything and not even knowing where that will take you to. But you do enjoy learning new things and listening to the researchers. And then as you chart your path and build the application or adopt new application, you learn a lot along the way. And so what I've learned is that, as Greta said earlier on, documentation is key. Every step of the way, it's great. It's really important to do the documentation. Even if you're doing software development, you're developing the application yourself. And I know many developers, there is that temptation to say, well, I'll build the application first, and once it's working and it's in production before I start doing the documentation. No, do the documentation on any new piece that you add. And then maybe down the road when you have the final version, and then you can converge your document. And thank God we do have AI this day, so you can actually develop nice documentation from using Claude as well. And so the other thing that I've learned is that not to ignore the researcher. So they are the expert. They know their environment. They know their domain more than I do. I'm a chemist by training, and I work with people I don't know who deal with nematodes, plant science. But I'm not going to pretend I know anything about plant science. But what I know is I understand how applications work and the compute system, the workflow, the workload. And if I get all of these parameters, I'm pretty sure I can put something together and have my researcher go through. I never assume that the technology is really so big for them. No, I always try to get their input. And so that's something that I have learned. And then taking note is really important. And then the other aspect of it is that we have a shortage of labor, especially when you're working on project, very complex projects where you have postdocs, grad students, you're doing software development. And so you have other projects that you're working on. Maybe you have 2 or 3 developers with whom you're working. They cannot develop the whole software stack by themselves. So you're going to have to figure out a way to bring the postdocs and the grad student into contributing to be contributing software developers. So what we do is create really good documentation and get started pieces of documentation, and so where they can start from and then learn to build. And so we establish CI/CD pipelines in a way that we can review the code that the graduate student or the postdoc is developing, give them feedback, and then iterate until we get a good product. In so doing, they are learning, and we are learning from them as well.
Let me go with that success story particularly for the students. When we are going to train the people, it has to start from the early stage of their education. So I started creating resources for undergraduate students to start using the computers, and sending them directly to supercomputer will make them cry or maybe say, I don't want to do anything, right? That's what they say. No, 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 I don't want to do it. I'm scared of it because they just know the word and they just want to say, and they said, once they want to do command prompt, they make a small mistake, even the space bar pressed accidentally. They said, okay, it's not for me, right? But when we start the early stages and they want put them in the Windows machine and they initiate this process and they get the success, they see the visualization, they do what they do, they understand. Then after that, move them to the supercomputers. They are doing extremely good. This I have seen for last maybe 6, 7 years or 8 years. The research students I have seen for last 10 or 12 years. They said, no, I don't know any commands, Linux commands, Unix commands, but when they started to slowly, it gradually improve, then they become very experts. And when they went to the PhDs, they really achieved a lot actually. So this is like slowly getting them into, and they enjoy doing it. And they also went for the PhDs and they completed PhDs, graduated, and they still start using the supercomputers.
Yeah, I think meeting people where they're at is really important.
So, one success story, kind of, that I had around this is I had a user who was using AI, an AI tool that we had released in order to do a thing, and they were using it very similarly to the way they had used, ChatGPT at home, right? And I think the real beauty behind this is, right, we had a good enough relationship where they just said, look, I'm not sure that I'm doing this right because I'm trying to get an output and it's just not coming the way that I'm expecting it. So I went to their office, we chatted a little bit, understood what they were trying to get to, and I said, hey, let's try prompting this in a different way. Actually, let's make a tool and not necessarily let the AI go with it, and shared that information and what my approach was. And in 5 minutes, we were able to solve their problem, and the machine wrote the code that we needed to do to perform an action, right? And I think the moral of this story is, as technologists, we need to continue to approach our researchers as experts, right? Maybe not in the same domain, but continue to represent yourself appropriately to them, and bring that information, respectfully to them. They want to learn from you as much as you will learn from them. And I think that's when we start to see real successes.
similar to what Jacob said about maintaining curiosity. Rajesh or Abhishek? Oh, sorry.
Yeah, I can go ahead. So one success story I can share that, once there was a user who has, lots of CSV files, and each CSV file has tons of rows, and each rows it has lots of columns. So they want to do some kind of training data, and he was using some kind of loop-based Python script, which kind of takes lots of time. So I just sit with the users, look at the workflow, and based on that scale, change the workflow so that they can use Slum array jobs, which actually reduce lots of wait time for him. So once I did this, and finally he was able to finish his workflow quickly. And then I realized that I need to also change lots of the way we provide the workshop, because we also conduct the workshop to train the users. So, but most of them are introductory. But then I actually change a couple of the workshop stuff so that we can also provide the training how to use lots of advanced kind of training where they can use this Slum tools to automate their workflow.
Awesome.
Actually, I would like to share some more points along with that. So someone said that in the residency meeting only. So success means that it not the count of how many tickets you resolve per day for the HPC team. It's only the way how you can measure how adaptively, easily researchers can able to do the tasks efficiently in all disciplines and collaborating together with and getting more grants and such kind of things. So I like that word. At the same time, in our university, what we will do is we will try to provide the HPC user training for every semester to all audience, as well as we will take one department, especially one department or institutions, and we'll provide the HPC and AI course, and that is 3 credit hour course we will offer, and people who are interested in that domains from scratch to senior level. So we will have low, medium, and high level approach, and our team will taught the course from advanced AI as well as the HPC environments, nodes and single nodes and everything. So we have seen the tremendous responses from the researchers, faculties who are taking this kind of credit courses, and we will offer every time rotation to each institutions and departments. So that way we can able to increase our services, and people can share the mouth of word to other researchers. Hey, I took this course and I learned a lot, so that it's helpful to me for the research like that. So we will show share those kind of things, and apart from that we will provide internal grants to all the internal faculties and researchers, like 30,000 or 40,000, and will provide credit hour service units freely to the specific researchers in different disciplines, and we will monitor to evaluate those kind of things. So based on that, we will try to go and see, elaborate the services and continue the approaches. Yeah. And in my point of view, success means that we could not continuously support to the researchers based on the software tools. So once, one or twice, 2 tickets is okay. For more than that one, it will why, because HPC resources team is very less and number of customers are in thousands. So any software tool, if you try to do, we could not provide constant support, then only we can say that the tool is very success in the research HPC team and AI team especially.
So we're with our last 5 minutes, maybe each of the panelists can take a turn and talk of either one point of advice that they haven't touched on, or a trend that you see changing the tools that you are suggesting or using. So maybe we'll start us off with Dina this time.
I prefer that adopting model. Right, the first thing is adopting model where the software is available and it is efficient use of it, and the resource is efficient. Another one, because there are not all the platforms are efficient to run the calculations, because even some of the GPUs will not work very well for some of the softwares, even when we adopt. So finding this efficiency is the important thing, and adopting the software is my suggestion and recommendation. Thank you.
Ted, final thoughts?
AI is here and it's with us. It's not going away. Be mindful of, as you're going through each of your tasks, to say, how can AI, right, approach this? Not just from how can it help this, how can it be used as part of the analysis, or how can this process even be used to analyze, right, machine learning from a perspective that's useful, right? Think about it different ways and apply it, and that way you'll stay ahead of the game.
Jacob, words of wisdom? Uh-oh, you're muted again.
Muted, so I noticed that. Yeah, so what I insist on is shared responsibility. So whether you are bringing researchers to adopt new technology or new software, or you're developing new software in collaboration with a research group, especially if it is a piece of software that they use most of the time in their research, you want to adopt some sort of shared responsibility. You can help them set up, but at the same time, they should own the application, understand it, know how to set it up, know how to maintain it. And if you are going to help, it should be minimal, because if our expertise is there, but we have a large pool of clients to serve, not just one. And if you adopt that degree of shared responsibility and they understand it, you actually make your job more lighter, and then you transmit knowledge and you can equally learn from them as well.
Great. Greta?
It's been great listening to like everybody's perspectives and experiences. It's really wonderful to be here. AI is absolutely changing everything, and the time frame of which how we create our documentation and our pilots and our proof of concepts and so forth. But I appreciate very much how people on the panel emphasize success as teaching our students and learning and teaching our community, being part of the community. So whether we're leveraging the tools, the containers, the Globus, the open on demand that's available in these communities, or whether we're learning new tools, it's just fundamentally, I just appreciate, I think there's a better synergy these days in terms of leveraging cloud computing, leveraging different kinds of software, the different kinds of software that we're developing as open source community, but also leveraging the cloud-based tools that are available to us.
Abhishek?
Yeah, I would say, that major trend is about, the AI-assisted tools or AI-based research workflows. So now we have seen that I would say, yeah, be responsible, as Jacob said, that be responsible for, what kind of workflow we are doing. So most of the cases we see that lots of users are now using VS Code and with AI, assistants, and they want to connect to the our HPC cluster with the VS Code, and they jammed up all the login nodes because they just want to use the VS Code to connect to our HPC system directly and then use AI tools to do that. So there are lots of processes are running on the login nodes. Is kind of difficult for the other users to run in the login nodes. So we have implemented some kind of limitations of the number of processes, memory usage on the login nodes. But I would say be mindful of what you are using. And we also have other ways to explore that. We also have used, there are lots of GUI applications, VS Code, Jupyter Notebook that can be available through Open On Demand. So yeah, I would say, yeah, be responsible for how you're using the AI tools.
Rajesh?
Yeah, I would like to say nowadays AI is changing everything as per Greta, and we need to be more careful and don't try to execute whatever the command it has given. Try to understand initially and try to execute accordingly. At the same time, now we recently have issues like everyone is downloading the LLMs in the computing nodes sometimes. Our vision LLMs are large volumes of data, those kind of things. So we need to be get ready initially to enhance our skill set and way behind the researchers, and how we can able to efficiently provide the proper workflow to the researches as per the custom requirements. So LLMs, AIs, are transformers and Hugging Face. Everyone is enthusiasm to incorporate those kind of new technologies into their research. But how efficiently they will work and the physical machines and the computing nodes, we need to know more carefully and provide the proper guidance to the researchers.
This was awesome. It was really good to hear everyone's different perspectives. And I want to thank all the panelists for participating and sharing their thoughts and taking the time out.
Yes, let's have a big round of applause for our panel. And I'm going to go ahead and stop the recording.